Now, this, well, I'm recording, yes, I hope so. This is a transfusor calculator, a typical example of the output of the inner party around here is the program, the generation program. This is two typical outlets. I'll turn those off and show you how I do it. That one goes off. Now the first calculation I did up here was for using just basic. This is the standard diameter. This is the one I made. I'm making a one like that. It's difficult to make, but easy. Oh, yeah. I didn't do that. Just again. Diameter wire. Millimeters. And I see it says 0.17. Not 0.17. Okay. It's similar. And the diameter formula is 28 millimeter. Length of formula, well, the formula I had before was 40 millimeters in diameter with a little bit extra for the things. The actual tube is 100 millimeters, you can buy them. This is 28 millimeter tube, 100 millimeters long, maybe 30 actually, I have to change it. So 28 millimeters long, 40 millimeters diameter, 100 millimeters long. Solve that, it's 40 millimeters length, so it's 40 millimeters. I'll do this for I've tried it. I haven't made calculation to just to try it out. Outside diameter of reaction tube is outside diameter of reaction tube. Well, that's the quartz tube that goes inside. And it's actually outside is the 9 millimeters of the borosilicate tube. Well, I've put 9 millimeters there. And the inside is the inside diameter of the quartz tube, if I can get one. They don't do them now. There's a lot of samples from me, but he got fed up with it. I was selling a ton. Ton of quartz is all that. To buy quartz is actually quite expensive. This comes to £30. I got them free from China without any samples. I'll probably go back to them for the proper production when they do it. Inside diameter of reaction is 6 millimeters. 6 millimeters. So that comes out with borosilicate tube, smaller borosilicate tube. Number of turns is see number of turns. Well, I said 50,000. The first one was 50,000. Second one 70,000. So if I repeat the first one, I'll just make it 60,000 turns in between. 60,000. 6,000. 6,000. Turns per hour. Number of hours. Diameter of cord is 114.7. It's quite small, you see. 114 millimeters. So let's see. 114 millimeters of diameter. Let's see. It's actually just it's can't see me, can you? Just done nothing. There's crap for that one. Can you? So 600. 114 millimeters. Small coal. Quite reasonable. New turns, no new turns. 2. Resistance inductance for our measurement. It's actually 69.6. I haven't got any means of measuring it. 69.6. 10, and then press return. Resistance 50 Hertz. My capacitance is a capacitance of 0.1 microfarad, 0.14 microfarads. So that's 0.1 microfarads, which is not very big, and we don't know exactly what it will be. You can have a slightly different size coil to make a difference in capacitance required. So try that. We don't know what different size coil. You have to go back. Let's see if it says no. Correct. Well, it says it doesn't do very much. It just measures just the calculation again. Should have done the returns again. Leave that alone. Dynamic impedance 47,000. Resonant frequency 50 Hertz. 1 parenthesis. 2 for another capacitance. 2 for another capacitance. That's just the resonant frequency. That's no good. So correct. Yes. Just try that. Fill 4 out. This 4 is wrong. For exit, 1 for exit. A section loops you back to the number of turns. RMS potential, well, I said 7,000 volts, which is what the plasma generation produced. But for that, so that calculation indicates in natural. Just all I do is take the concentration of determining natural hydrogen, work out the proportional values, 5,000 watts. If it was pure deuterium, calculation that this is from pressure to pressure, just pressure, that's all, and it's based on physics, is 2 times 10 to the 11 watts, which is quite a lot of power. So what I suggest you use is nitrogen mixed with nitrogen, which is inert, mixed with deuterium. And deuterium react. Now I don't know what a nitrogen reacts. Might have a cross section, I don't know. But it's ionized. Nice. Do loop. I wonder what the loop does. This starts to RMS, which is well 8,000 volts. That brings the power up a bit more. Also has the peak current 0.3 and the peak current 0.4, which is indicated will be. It's above the ampere sensors. That's 60,000. That's quite a reasonable number. 1x. Now that again, 2 again goes to this calculation again, so we test it again. So much of 5.17. Be strictly to it. So much of 4. So this time I'll try and make a different size, so I'll make it 30mm. Which might be easy to do. Length of 4. That's a 4mm. It's actually, I said, what's 40mm? So all these can be varied. The power will depend on the size of the capacitor of the cavity as well as the pressures and so on. Okay, so 40mm. That's our diameter of reaction tube. Again, that's 9mm. The inside one diameter is 6mm. Number of turns, everything. So, knowing that 70,000 turns or bigger, I can't make 100, that doesn't go up to 100,000, make it 90,000. be very difficult to wind. The induction one is now 129 newtons. Inductance by measurement 179. Can't see very well on these notes. Does that work? Thing double. Resonant frequency again 50 Hertz. Correct. No, I don't know. It has to be yes, because if you change it, it's won't fix it. And that gives you the winding mass is as well as 5 kilograms, it's far too heavy. And the thing is too big. So that's no good. Down to 160. Well, let's press about that. And foot winders was around 7,000. It's actually a smaller amount of power generated when it's 100 and smaller by other ones, so that's no good. That's no good at all. So I'll do that one again. That was no good. That was a daft calculation. Anyway. It's to do with the diameter of the winding. So if I reduce the size of the tube from 28 millimeters to 25 or 20 millimeters, 20, it's a little shape, and the diameter of the former, sorry, diameter, that's wrong, start again, scrub that out, so I'll remove that way now. Oops, second. You couldn't see that. That doesn't look right. You're going to execute this as a run execute. There's that window. Window's gone. But the formula actually is quite a complicated formula. It's the first part is just a calculation of inductance down here, and then we go on to get the extra thickness of words and power that comes down here somewhere. And I should do this calculation inductance loop. Turns loop is that up there, turns loop. So it's different capacitors. You actually need that capacitance loop. I can put that down to turns loop. So I'll take that, change it. You have to be explicit with these. You have to go to the explicit. What happened? Ah, it's jumped. Oh, well, why did you do that? Oh, shit, it's no good, this thing. It's because I've pressed the wrong place. Turn that on. Just trying to edit this out into a turns loop. Because you can put numerous other forces in this. Turns loop. With calculators, you can just make a guess like that, but it has its disadvantage because you can get it all wrong. Crash the whole system, start again. Right, then done for a while, you see, this gives more flexibility. See, when you request this new number of terms, some interesting calculation. Done for a while, I want some. Diameter of formula. See, diameter. Now this is where we have a shorter formula, it's 20 millimeters. Length of formula. Now length of formula, well, length of formula would have the same 40 millimeters length. Otherwise it gets in the outside diameter ration tube, that's 9 millimeters. Inside diameter 6 millimeters. Any old tube would do. Number of turns, that's quartz tube inside a borosilicate tube, don't have to do that. Now, I said 70,000, didn't I? It's 43, you see, laptops. Ejectors, well, measurement. There's only 48 Henry. That's 50 hertz. That's 0.2, that's far too high. That's 0.2 as I had before. So it's 0.2. So that's actually a different arrangement. try to small inductance. And that's no returns. It starts giving no returns. No returns again. No, that's wrong. Yeah, that's too much. That's obviously not doing it right. And the inductance resistance is 0.1 millimeters. 0.1 millimeters is not reasonable. That's 2.1 millimeters. In fact, that's actually it's very interesting. That's different. So I'll try again. And that number of times won't work because it's got to be the diameter of the fire. Interesting. So the inductance must depend on the size of the fire. We'll carry on working it out. Number of turns again. So 60,000, 50,000. You might go 24. So it's just one measurement. 24. 6. That's actually got meters coming to that. Jet resonant frequency 50 Hz. It's got 0.4 microfarads. That's not really good for anything. Sorry about that. So that's actually more power generated because it's a smaller inside bit. The inductance is so it's a much better design. Power generator one actuation is actually getting on with it. So that's reasonable. So that's a number of calculations we've done there, and that shows that with a smaller tube inside, more power. So that could be extended because that's got the kind of a glass tube without the plastic tube mounting is only 20 millimeters. Looking with that one. So that's simple. So that's sort of with the actual calculations based on physics. I can't remember where it all came from, but it's based on the pressure that's tested in you can look up the Wikipedia. It's in there, the actual pressure needs and the formula for the pressure. It's all there. Okay. So I've got two formulas now. One for the dust different turn, and that's all it does. That's quite interesting. I think I used to make a 20 millimeter hole in a tungsten. So I think it's got 5 millimeter hole. So the house is 20 millimeters. 20 millimeters is quite short. So the geometry is quite reasonable. stop there. Interesting. As I say, I can't see it. Stop recording. How do I stop recording?